Hey guys, welcome back to my channel and I hope you are all doing extremely well. This is lecture 14 on linked list series. So far I covered 13 lectures and from lecture number 4 we started solving actual linked list problems and I'm mostly picking the medium level problems because I believe these kind of questions will help you to grab the more knowledge on the linked list, and I highly recommend you to please start watching from lecture 1 till whatever I'm going to post in my lecture. And at the end of this series, I strongly believe that you will be in a situation to solve any linked list problem thoroughly. Without further delay, let's get into today's lecture. Let's solve this problem. So this is medium level problem from lead code and problem number 1721, swapping nodes in a linked list. Let's try to understand the problem statement. So we are given one list along with a k value. The goal of this problem is we need to swap the values of kth node from beginning and kth node from end. Let me go to the diagram and let me explain you in a better way. If my list is something this 1, 2, 3, 4, 5 and 5 is next is null, and if my k is 2, the ultimate goal here is what is the kth node from beginning? This is one index based list and assume like that. Uh, Here the second node from beginning is 2. What is the second node from end? 4. The goal here is we need to swap 2 with 4 and 4 with 2. The values we need to swap. So once we done that, so what is the output is going to look like? 1, 4, 3, 2, 5 and 5 is next is null. So this is what we need to return. So that's all the problem statement. So we need to swap the kth node from beginning and kth node from end values. That's it. Let's see how we can solve this problem. If my list is something like this, 1, 2, 3, 4, 5 and 5 is next is null. If my k is 2, what is the Naive approach? The Naive approach can be you can count the number of nodes first, number of nodes, okay, and based on that result, you can go to kth node from beginning and you can go to the kth node from end. Okay, then at the moment when you reach to the kth node from beginning, kth node from end, then you can swap the value. So when you know the count of number of nodes in the list, that is going to be very easy, right? So what is the time and space complexities with this? So big O of n is going to count the number of nodes, and big O of n is again going to reach the nth node from last and kth node from last and kth node from beginning together. So the average it is going to be big O of n. What is the space complexity? The space complexity is going to be big of one because we are not taking additional data structure. Okay, so this is how the simple process it is. Now let's try and see how we can write the code for this before going to the other way of solving. The first thing here is we need to check if head.next is equals to null. Why I'm taking head.next? Because the number of nodes in the list is minimum going to be 1. Okay, that's the reason I'm not checking head equal to null. If head.next is null, then I'm going to return the head. Otherwise, what I'm going to do first, int len is equals to 0, and I'm going to take a cur pointer, cur node I mean to say, head, while cur node not equal to null till this condition satisfies, then I'm incrementing my len and I'm moving my cur node by one position. Done. At the end of this one, and I'm going to what I can say have the number of nodes in my list. So the next step is too simple to reach the first kth node from beginning. So for int I equal to let me take a new reference, list node first. Okay. it is going to point to the head only. So how I can reach to the first kth node from beginning? It's too simple, right? For I equal to 1, I less than or equal to k, I plus plus. Then till this condition satisfies, what you need to do? First node is equals to first node dot next. So let's see how it is going to be. If my k is 2, okay, initially first is going to point to the node 1 and my k is 2, 1 less than or equal to 2, that condition satisfies. Then my first is going to the, let me go to the diagram, not an issue for me. Here we can see the same condition, 1, 2, 3, 4, 5, 5 next is null, right? And I'm initially at this position. Then what I'm doing here is for I equal to 1, I less than or equal to k. That's what I'm doing, right? So k equal to 2 here. So what will happen? 1 less than or equal to 2, condition satisfies. Then k will become here. Then 2 less than or equal to 2, still condition satisfies. Then I'm going to here. So this is wrong because this is pointing to the third. So how I can restrict this? So the simple is I less than k. Okay, that means it is going to point to the kth node because you're starting from 1 and you are already pointing to the first node only. Okay, then you need to reach till I less than k. So in this case, what it is going to be 1, 2, 3, 4, 5, 5 is next. So if initially f is here, so I equal to 1, 1 less than k, k is nothing but 2, condition satisfies. Then my first is going to point here, then I will become 2, 2 less than 2, condition not satisfied. Then I'm at the kth node from the beginning. Okay, let's change in the code, k less than, yeah. So it's done. Now we need to find the last node, I mean kth node from end. So what I'm going to do here is list node second is equal to head, and I request you to please pay some attention here. So for int I equal to 1 and I less than or equal to len minus k I plus plus. Let's see what is going to do len minus k. Okay, and if my list is something like this, 1, 2, 3, 4, 5, 5 next is null, and my len is 5, my k is 2, 5 minus 2 is going to be 3, and I'm starting from here. So I equal to 1, 1 less than or equal to 3, condition satisfies. Initial it is here, then my pointer is going to point to the second one. Then I will become 2, 2 less than or equals to 3, condition still satisfies. Then my pointer is going to be at here. Then I will become 3, 3 less than or equal to 3, condition still satisfies. Then my pointer is going to point to the 4 here. Then I will become 4, 4 less than or equal to 3, condition fails. So at the end of this condition satisfies, so I am at the kth node from end. Okay. And what you need to do here is second is equals to second dot next. Great. So once you've done that, the only thing here is now your first node is pointing to this, your second node is pointing to this. The ultimate goal is first node dot val should be second node dot val and second node dot val should be first node dot val. They are asking us to change the values. You can see here swapping the values. Okay. Then it's just a swapping two numbers concept. So val temp is equals to second dot val I took, then second dot val is going to be first dot val, then first dot val is going to be temp, and at the end just simply return your head. That's all. Let's give a run. Yeah, Let's submit. You can see here it got submitted successfully, and this is the one way, okay, to solve this problem. And I have another way also for this. Let me jump to the second way. So the second way here is you no need to count the number of nodes, okay, but you need to leverage the concept of two pointers, okay. Let me explain you. If my list is something like this, 1, 2, 3, 4, 5, 5 next is null, then what I'm going to do here is case 2. And I'm going to have two pointers, one is slow and other one is fast. And I'm going to move my fast by k positions, and then I start moving my slow and fast till my fast is not equal to null. And with the help of this approach, I will be at the position of kth node from end. Okay, for kth node from start, we use the same concept which we used in previous approach also. But for kth node of end, we use this approach. In this way, we no need to count the number of nodes, right? Let me explain you here how we can reach to the. I hope like you guys are getting how you can reach to the kth node from beginning, right? That's too simple as I shown in previous approach. But going to the kth node from end is a bit different. So let me explain you. Initially, my slow and fast pointers are going to be here, head. Then what I'm going to do here is I'm going to move my fast by two positions. That means I equal to 1, I less than or equal to k. So I equal to 1, I less than or equal to k, condition satisfies, then my fast is going to be here. Then my I will become 2. 2 less than or equal to 2, still condition satisfies, my fast is going to be here. And then I will become 3. 3 less than or equal to 2, condition not satisfying. And when this condition not satisfying, I am come out of the loop, and by the time my fast is going to point to the 3, my slow is going to point to the 1. Now the simple approach is I need to move my slow and I need to move my fast till my fast not equal to null. Okay, let me take a different pen and explain you. Is my fast null? No. Then my fast is going to be here, my slow going to be here. Is my fast is null? No. Then my fast is going to be here, my slow is going to be here. Is my fast is null? No. My fast is going to be here, my slow is going to be here. Is my fast is null? Yes. Then I come out of that loop also. And now you carefully observe your slow is pointing to the kth node from the end, right? So this is that much simple. So you already know how to reach to the kth node from beginning, and you already know how to reach the kth node from end, and just do the swapping. That's all. So what are the time and space complexity? The time complexity is going to be still big O of n. The space complexity is going to be big O of 1. And this is a bit optimized compared to the previous one, because like you don't need to do that additional operation to count the number of nodes in the list. Okay. Let me go to this coding part. So the base condition remains the same. Okay. And now the ultimate goal here is first you need to reach to the first, I mean, kth node from beginning. Okay. First, let's go to that. List node first is equal to head for int I equal to 1, I less than k, I plus plus, and every time this condition satisfies, my first is going to be first dot next. I'm done. I'm done with this. Now I need to have two pointers to reach to the kth node from end. So initially list node slow is equal to head, list node fast is equal to head. Now I need to move my fast by k positions. For int I equal to 1, I less than or equal to k, I plus plus until this condition satisfies, fast equal to fast dot next, and I'm done. Now while fast not equal to null, till this condition satisfies, what I said, just to move slow by one position and fast by one position, fast equal to fast dot next. Now you are pretty much done with this. and at the end of this loop, so your slow is going to point to the kth node from end. Just take a same concept like val is equals to slow dot val. Uh, Slow dot val is going to be first dot val, and first dot val is going to be val. That's all. So at the end, just return your head. Let's give a try. Yeah, it got passed. Let's submit. Yeah, you can see here it is bit faster. Of course, we no need to trust the lead code time runtime every time because that depends on lot of factors. But if you see the program, okay, so this is much easier and much bit faster than what we did previously. Okay, so I hope you learned something new today. Please do subscribe to my channel, and I'm going to post more valuable content in future. And if you find any difficulties in understanding this problem, please do let me know in the comment section, and I will be very happy to explain you in detail. Thanks a lot. Bye bye.